Hello everyone. In this video, we're gonna solve problem of the day, which is check for binary search tree. As you know, BST is the root node always be the mid value of sorted array, which means the left side of a node should always be lesser than the root node. Look at this subtree left. Look at this subtree. This is the left hand side of the binary search tree. Here the leaf node is 1 and root node is 2. The root node is always greater here. The leaf node are always a lesser. For an example, for a node 1, the root node is 2, which is the root node greater and the leaf node is lesser. Similarly, if you look at the right hand side, the leaf node is always greater and the root node is always lesser. If you look at 5, the root node is 3, the 3 is lesser than 5. Similarly, for 3, the root node is 2 and the root node lesser than the child node, right? This is a condition for a binary search tree. You can also refer this definition. So, this problem we can solve by using min and max pointers. If you circumstantially think for a root node there is no minimum, there is no maximum, so we can assign maximum value as a maximum, which means integer dot maximum, and minimum value as minimum, which is integer value dot minimum. I'm gonna assign this maximum value as infinitive and minimum value as minus infinitive. Okay, then then we need to traverse the entire binary search tree and we need to check whether that particular node is greater than or equal to root node or not. Now I'm going to traverse a left node. Here we need to pass the maximum value of root node because that's what we are going to check here. Here I'm going to pass the argument as 2 and minus infinity. Here 2 is greater than or equal to 1. If it is true, we need to pass the next argument. If it is not, we just need to return false. Okay, similarly we need to traverse right hand side. Now we need to pass maximum value and minimum value. Maximum value is infinity, minimum value is 2. Now we need to check 2 is 2 lesser than or equal to 3. Yeah, it is true. Now then we need to pass next. Here we need to pass left hand side as 3. 3 is the maximum value and minimum value is 2. If we pass here, there is no value. The root is null. So we need to return it. Return as true or return as true. Now on the right hand side we will pass infinitive and 3. If you check the condition it will be true. So if all the condition is true we need to return true. If you circumstantially think the base case is root, if the root is null, we need to return true. Okay, this is what is the base case is. So I'm going to write here. Initially let us assume we'll create a new function for that node, and we're gonna use two pointers, which is int max, int min. Okay, if root is null, what we are going to do is return true, right? Then we need to traverse. Then we need to check if root dot data. Look at this. This is a root. Root dot data should be lesser than maximum value. Should be lesser than maximum value, and root dot data should be greater than minimum value, right? if it is if it is true, we need to traverse. If it is not true, instantly we have to give false statement. So then what we are going to do is we, we are going to use a recursion for check the entire BST. Here I am going to give left hand side, and maximum value will be root dot data, which is 2, and the minimum value will be minimum of the root. BST, sorry, and check BST right hand side, root dot right, maximum value, and root dot data. Here we need to pass the initial values, that is mine greater infinite plus infinitive comma minus infinitive. Yeah, yeah, the output is correct. If you like, thanks for watching.